All right, good morning. We are having a little bit of trouble with system of equations, so I want to go over kind of an introductory lesson with that, and it's something you can definitely handle, but it's definitely tough not having a class time to discuss it. So first thing you see here is we have system of equations. Really, you're looking at equations of linear lines right now, and if we're talking about a linear line, right? Straight line, right? Lance, there we go. I've got some scraps here. I'm building a built-in bookcase. I'm very excited about that. But basically, we have a straight line, right? This is an equation. And when we're talking about systems of equations, we're really talking about just two equations or more. And so we have two equations here. One is a straight line, and the other equation is a straight line. And there's only three outcomes when we're talking about system of equations. You can see right here in front of you, you can have one solution. And what that looks like is, let's say I have a line going this way and I have another line going that way, and where they intersect is what we would call a solution. So you can have one solution, and you can see right here on the paper in front of you, you have the red intersecting with, excuse me, the yellow. The other option is you could have no solution. So imagine that you have a equation that is a line, and then you have another one that is right under it or right next to it. Or we call these railroads because they are parallel. Will they ever intersect? No. If I keep my hands straight, they won't. So if they'll never intersect, they have no solutions. And finally, the third one is the infinite amount of solutions, which is, you know, kind of hard to think about at first, but once you do a few of these problems, you're going to realize what's going on. So what if I have a line that has a slope? All right, it has an equation, and it looks exactly like the other line, right? So they're going to overlap each other. You're not going to be able to see the difference between the two lines, but everywhere along that line, right, they're intersecting, they're touching. So how many solutions do we have? Well, we have infinite amount. It goes on forever. There's really no end there. And so you can see where the two lines join right here. So I'm going to do a few of these problems on the unit test. It does take a little bit of work, and so now we're going to have to figure out, we have kind of a general idea of what we're looking for with system equations. Now we have to actually use algebra, and a lot of these are kind of, I call them like riddles a little bit, because you have to decode what you're supposed to be doing, and so you have to set up the problem, and then you have to execute. So there's a lot of work that is being put on the student here, but it's definitely worth it. So let's go ahead and want to make sure it's all recording. Looks like we're good. All right. Unit test here. I'm going to be hopping back and forth between uh, my little writing pad because I can't really, I don't have enough room here to write on this. But first question is, it says, how many solutions does the system have? So again, it either has one solution, has zero solutions, or it has infinite amount of solutions, right? So we're in the form y equals negative 5x minus 1, and that's one equation. And the second equation is y equals negative 5x plus 7. So these are not the same equations. I know that seems odd, but sometimes you'll see the same equation and you just have to simplify it down or have it solved for y or x or just y, and that way you can see it. And I'm going to try talking the way that we've come along in our compacted class learning about algebra. So we had three answers. Is it one solution, no solutions, or infinite? And it wants us to use the graph. So let's go ahead and use the graph here. Some of you already kind of know what's going on, but let's use the graph. So y equals negative 5x minus 1. So the y-intercept is negative 1. So I'm just going to put that right there as our negative 1. Remember, our slope is negative 5 over 1. Remember, it's rise over run. So we're going to go down negative 5. So we got 1, 2, 3, 4, 5. And it's a positive 1. So it's going to be actually like this. Okay, so that's our line. And it is a negative slope. And we can tell by the negative there. And the next one is negative 5x plus 7. So our y-intercept is going to be on 7. There we go. And we got the same slope. Well, some of y'all already kind of figured this out. 1, 2, 3, 4, 5. If you have two equations, different y-intercepts, but the same slope, again, it's going to look like two railroad tracks going right next to each other. And I promise you, I challenge you to follow those railroad tracks and see if they ever cross. You're going to be walking for quite a while because they will never cross, right? And so you're going to have how many solutions? You're going to have no solutions. And you can see that right here on this problem. And really good job, really good job. All right, so next question here is, this is where we kind of run into some headaches, right? Remember, system equations, do I use it every day? Nope. But in a lot of manufacturing, a lot of engineering jobs, a lot of production, this is very important. Do they do it every day? No, it depends on what your job is. So, but being able to understand what you're looking at is very essential, just being a normal citizen here. So keep that in mind. Just because you won't use it every day doesn't mean it's not worthwhile to learn. So Marcelina uses a blend of white corn and yellow corn to make tortilla chips. Okay, white corn and yellow corn. At her restaurant, there used to be a place on Plainview, Texas. I always drive up there for Special Olympics on Saturdays, and there was a Mazda factory right there off of the interstate. So I thought that was pretty cool. She needs to buy 50 kilograms of corn in total for her next order. White corn costs 30 cents per kilogram. Yellow corn costs 15 cents per kilogram, and she wants to spend $12. A lot of stuff going on here. Here's a graph that shows a system of equations for this scenario where X is the amount of corn she buys and Y is the amount of corn she buys. So it's already set up the equation for you. What you're looking at is if we had worked this out, you would come to this point right here, 20 and 30. So you know how to use a graph, and some of y'all are in high school economics. You know kind of what we're looking at here when we do production possibilities curves and things like that. So line A represents it's the yellow, so it's the 30 cents of white corn plus the 15 cents of per kilogram equals $12. So we have the weight, the total amount quantity will equal 12, and then line B is X plus Y. And so that's just the weight. My bad, I got backwards. X plus Y is just the weight. So how many kilograms of white corn and how many kilograms of yellow corn did she have to get 50? And then we actually have the different price and quantity. So, what does F represent in this context? And so, is X on either one of these lines? This is why I like bringing up economics, because this is a big point of when we're doing production possibilities curve. So we have basically two lines right here, and they're crossing, and we know that a possible solution is right there where they cross. F is not on either one of these lines. F is not, inside both of those lines, and so one thing, F is not a solution. Let's just get that out. Marcelina spends the intended amount of money and buys the intended amount of corn. Doesn't look like it. Doesn't look like she's being very efficient, and this is what you would look at with economics. Is she being efficient? No. Marcelina spends the intended amount of money and buys more than intended amount of corn. Not seeing that either. Kind of looks like she's spending less and getting less, right? Marcelina spends less than the intended amount of money but buys the correct amount of corn. Did she buy the correct amount of corn? Does it add up to 50? No, it looks like we have 15, 15, 30. Marcelina spends less than the intended amount of money and buys less than enough corn. So it looks like she spent less. Right here. All right, let's go ahead and try that. There we go. And some of these you just have to kind of talk your way through it, or ask people, kind of work your way through it together. A fruit stand has to decide what to charge for their produce. They need $5.30 for one apple and one orange. They also need $7.30 for one apple and two oranges. We put this information into a system of linear equations. Can we find a unique price for an apple and an orange? Okay, so can we find a unique price? So they need $5.30 for one apple, one orange. So that'd be one apple plus one orange equals $5.30. So to be, I can write on this one for you. Okay, so I'm turning this sentence into an equation. So a lot of times you'll see when they do these examples, they're going to do X and Y. I like to use variables that I can remember. So for apple, I'm going to use A. So one apple plus, one orange, and that might get confusing seeing a zero there, but that's orange, equals 5.30. All right, and that's exactly what that said right there, and I just wrote it. Now our second equation is one apple plus two oranges equals 7.30. Now these are two equations, and I can actually solve this stuff. So are there going to be many solutions? Well, I don't think so. All right, are they the same line? No. Um, is there, the system has no solution? I don't agree with that either. Actually, I'm going to go back. Maybe there is many solutions. I apologize. So let's take a look here. So the way we are going to solve this, and let me write on a little bit bigger sheet of paper here so that we all can see it. So we have that is a 1 apple plus 1 orange equals, I think it was 530, and I'll go back and change that. 1 apple plus 2 oranges equals 730. Okay, and so when algebra, with a regular equation, we're solving for one variable. Now we have two variables. How do we do that? Well, we have to set one of these equations to solve for one variable. You can pick either one you want. I usually pick the bottom one. And again, the way I'm solving this is going from the way we've learned. Now, there's other ways to solve this. So I'm trying to go off of what we have learned. And so that's kind of like we're building on what we've done. Now, obviously, there's many ways to do math. Don't ever be told that there's only one way to do it. But I'm going off the way we've learned this past year. All right, so I'm just going to go ahead and solve for A here. So I have 1A. How do I get rid of this 2 oranges? Well, I'm going to subtract it, and where does that go? Well, that goes to the right side of the equation because we are balancing the equation. So it's 1A equals $7.30 minus 2 oranges. And so now I have, for A, I can substitute 730 minus 20 everywhere I see A. So I'm going to substitute this into here, right? And, I can get rid of that 1. So now I'm going to rewrite. And yes, I know you probably lost a little bit the way I'm writing here. But I'm rewriting this equation. So where I see A, I'm putting $7.30 minus 20. And then I'm going to do, oh, my bad. I messed myself up. 2 oranges, my bad. Ah. Bear with me. You see how I made my mistake there? I thought that was 20. That is 2 oranges. Maybe I should do that. 2 oranges plus 1 orange will equal $5.30. And so we've got the 730. I can subtract it to get rid of it. And so 530 minus 730 will give us a negative 2. Make sure that is in there. Then we have negative 2 plus 1. What will that give us? Well, that will give us negative 1 orange. And at this point, negative 1 divided by negative 1 is 1. Negative 2 divided by negative 1 is 2. So how many oranges could we get? 1 orange is $2. All right, so that is 1. Could I figure out what apples are? Well, now that I know that this is 2, I can plug 2 back into either equation. It doesn't matter. So that'll be really A plus 2, and then we'll subtract. I know that I'm making it not easy for you. We'll subtract 2 here. So that'll be $3.30. All right, so I did not make that as easy as I could have because of I just kind of write all over the page. But recap, you simplify one of the equations, you solve for one of the variables, then you substitute that variable into the second equation, then solve for that. You'll get one of the answers, and then you can come back and solve for the other answer. So we have a solution here, okay? All right, so they should charge $2 for an apple and $3.30 for an orange. Nope, I got it backwards. They should charge $3.30 for an apple and $2 for an orange. Let's check it. There we go. Really good job. A lot of your questions can be like this. All right, so I love this stuff. It's kind of fun. Kevin is 3 years older than Daniel. 2 years ago, Kevin was 4 times as old as Daniel. So Kevin is 3 years older than Daniel. So let's go ahead and let's write that equation. Remember these riddles like, oh, Bobby is 42 years older, how old is Christy? Stuff like that. I remember these as a kid all the time. They were frustrating because I didn't know what I was doing. But let's see if we can figure this out. Kevin is 3 years older than Daniel. So let's say 3, got to do the little writing thing. 3 plus Daniel equals Kevin, all right? I think we can agree with that. 3 plus Daniel equals Kevin. So 3 years older than Daniel, and that's what Kevin is. So the second one is 2 years ago, Kevin was 4 times as old as Daniel. So how would I write that? So I'm going to write again. Kevin was, so we could say 4 times as old as Daniel. So should I do 2 years ago, should I subtract 2 years from that? Or should I do 2 minus 4D? What do you think? I'm trying to see it in my head. 2 minus 4D, 2 years ago. So do 2 minus 4D. All right, and I'm going to clean that up a little bit. All right. So 2 years ago, Kevin was 4 times as old. So if we got rid of that, so we could say Kevin is 4 times as old. All right, so let's, oh, my bad. Which system equation represents this situation? I wasn't even reading the answers. Let's see if we're anywhere close. So I'm looking for Kevin. Let's look for the first equation, 3 plus D. 3 plus D. There we go. I like that. And B has it too. Okay. All right, so we've got that. So that could be a solution, or D could be a solution, because I know I got that right. Now the second one was, well, maybe I wasn't really paying attention or understanding. I did 2 minus 4D. And so we have Kevin minus 2. 2 years ago, Kevin was 4 times. So it'd be 4K minus 8. And then I would bring that over. I'm not seeing that. What about this? 4D minus 2. So if we're writing this out, we'd have 4. Come on, give me something right here. Not going to let me write there. We'd have 4D minus 8 equals, I can't write K minus 2 plus 2. So it'd be K equals 4D minus 6. I'm going to go with that. There we go. All right, let's do one more question. And I didn't set it up correctly on that one. All right, that's my fault. Logan genetically engineered a new type of fir tree and a new type of pine tree. Well, Logan should be making some money, because it's really hard to do that stuff now. At least make something that's worthwhile and worth spending money on. The combined height of one fir tree and one pine tree is 21 meters. So again, we have a combined height of one fir, and so hopefully I don't get confused with my variables here, and one pine plus one pine equals 21 meters. I'm just going to write this out. I need to quit confusing myself. The height of 4 fir trees stacked on top of each other is 24 meters taller than one pine tree. So how tall are these types of trees? All right, so 4 fir trees on top of each other is 24 meters taller than one pine tree. So let's make sure I'm writing this right. So first thing is, the equation I came up with for the first one says a combined height of one fir tree and one pine tree is 21 meters. One fir plus one pine equals 21 meters. That is literally what that is saying as an equation. The second one is the height of 4 fir trees, so 4 times 1, right, is 4F. Stacked on top of each other is 24. So the height of these will equal one pine tree plus 24 meters. And so we're trying to figure out how tall each fir tree is. And so I'm going to go back to my little writing pad here. I'm going to do the best I can to write as clear as I can. So we have fir plus pine equals 21. And then we have 4 fir equals 24 plus pine. Let me make sure I got that right. Okay. Now these are our two system equations. We can do this pretty little thing like that. I didn't do it very well. I'm going to simplify this second one. I'm going to go for that. I think it's going to be a little bit more fun for me. And so what I'm really doing is I'm going to solve for f. Remember when we're trying to rewrite equations and y, and you want to have, you have to rewrite it, simplify it. That's what we're doing right now. We're solving for f. So I'm going to rewrite this equation. 4f equals 24 plus p. So I'm going to divide both sides by 4. So I can divide all of that. So 4 divided by 4 is 1. That leaves me with 1f or f. 24 divided by 4 is 6. And then I have p over 4, just like that. All right. Now, I've got to add this back to that equation. All right. So now everywhere I see F, I'm going to substitute. My bad. I'm over here overthinking what I'm doing. So if I have F right there, I'm going to do 6 plus P over 4 plus P equals 21. And I made this harder than I should have. So I'm going to subtract 6 from both sides. And that will leave me with P over 4 plus P equals 15. There we go. All right. Starting to slow down here. Got 15. Now, is this making sense to me? Okay. All right. Let's try it out. All right. So now we have P over 4 plus P. We can't combine those because we don't have the correct. So we have to do, we got to multiply this by 4. That's really going to be P plus 4P over 4 equals 15. So that'll be 5P over 4 equals 15. How do I get rid of that? Divide, which is really multiply by the reciprocal. Yes, a lot of work, right? So then we have 5P equals 60, right? And I can't get rid of that right now. So we're going to divide both sides by 5. And so we have, let me see if I can put myself, we have the pine tree is 12 meters tall. And so if we already have P now, we can plug that back into our first equation here. So that was F plus P equals 21. So if I do that, I'm going to F plus P equals 21. And I apologize, I was trying to just erase that last one. So F was, we don't know, and P was, I think it was 12 equals 21. We substitute that in. We subtract both sides by 12. All right, it's getting fun, isn't it? And then that'll leave us with F equals 9, right? All right. Woo! So the pine tree was 12, and the fir tree is 9. Let's see how we're doing there. The fir tree is 9, and the pine tree is 12. There we go. All right, it's a lot of work. No one's denying that, but the reason why you're in this class is because you are willing to put that effort in. Please talk to me about any of this stuff. We have a meeting today, all sorts of help. It's not, I'm not going to say it's not hard, it's tedious. And being away from you makes it harder to teach it to you. So come to the meeting today, one-on-one tutoring, stuff like that. And hopefully you have a good one. All right, see ya.